Determining the storage requirements of film involves understanding the different types of film and their specific needs. Firstly, let's discuss cellulose nitrate film. This type of film is highly flammable and unstable, requiring specialized storage in a vault with temperature and humidity controls. It was typically produced before 1951. If it is still in circulation, it must be stored in accordance with National Fire Protection Association 40, which is the standard for storage and handling of cellulose nitrate motion picture film. Secondly, we should consider safety film. Safety film is made of non-flammable materials such as cellulose acetate. It is generally safe for storage in ambient conditions and is less susceptible to degradation than cellulose nitrate film. It can usually be stored in a regular storage room. Thirdly, there is polyester film. Polyester film is extremely durable and stable and can be stored in ambient conditions indefinitely. It is resistant to deterioration and fading. To determine storage conditions, there are several factors to consider. Firstly, the age and material of the film are crucial. If the film is older than 1951, it is likely cellulose nitrate and requires specialized storage. If it is newer, it is likely safety or polyester film, which can be stored in ambient conditions. Secondly, the physical condition of the film needs to be evaluated. Inspect the film for signs of aging, deterioration, or damage. Brittle or torn film may require special storage to prevent further damage. Thirdly, the storage environment plays a vital role. Ideal storage conditions for safety and polyester film include a temperature between 50 to 70 degrees Fahrenheit, which is 10 to 21 degrees Celsius, relative humidity between 30 to 50%, and darkness to prevent fading. If you are dealing with cellulose nitrate film, there are specific vault requirements that must be met according to NFPA 40 standards. The vault must have fire-resistant construction with automatic sprinklers, temperature and humidity controls, and a ventilation system to prevent gas buildup. It is important to be aware of the safety considerations associated with cellulose nitrate film. It poses a significant fire hazard and should only be handled by trained professionals. Avoid storing it in close proximity to other materials or flammable liquids. Do not attempt to rewind or handle it without proper training. For additional resources, you can refer to the National Fire Protection Association NFPA 40 and the Association of Moving Image Archivists for Film Storage Guidelines. It is strongly recommended to consult with a professional film archivist or preservation specialist to ensure proper storage and handling of valuable film collections. Now let's delve into the technical aspects of film storage to provide a more comprehensive understanding. Cellulose nitrate film, due to its chemical composition, is inherently unstable. It decomposes over time, releasing flammable gases and potentially leading to spontaneous combustion. This decomposition process is accelerated by heat and humidity, hence the need for strict temperature and humidity controls in specialized vaults. The NFPA 40 standard outlines specific requirements for vault construction, including fire resistance ratings for walls, ceilings, and doors. These ratings are typically expressed in IRs, indicating the duration for which the structure can withstand a standardized fire test. The standard also mandates the installation of automatic sprinkler systems designed to quickly suppress any fires that may occur. These systems often utilize specialized nozzles and flow rates to effectively extinguish fires involving cellulose nitrate film. Ventilation systems are crucial for removing the gases released during decomposition, preventing the buildup of explosive concentrations. These systems typically incorporate air intakes and exhaust fans to maintain a constant flow of fresh air within the vault. Temperature and humidity control systems are designed to maintain stable environmental conditions, minimizing the rate of film decomposition. These systems typically involve air conditioning units, humidifiers, and dehumidifiers, all of which are controlled by sophisticated monitoring systems. Safety film, while less hazardous than cellulose nitrate film, is still susceptible to degradation over time. Cellulose acetate film, a common type of safety film, can undergo a process known as vinegar syndrome, where it releases acetic acid, causing the film to shrink, warp, and become brittle. This process is also accelerated by heat and humidity, making environmental control important, though not as critical as for cellulose nitrate film. Polyester film, being chemically inert, is the most stable type of film and can withstand a wide range of environmental conditions without significant degradation. However, even polyester film can be damaged by improper handling or storage. Scratches, abrasions, and exposure to ultraviolet light can all negatively impact the film's quality. When inspecting film for signs of deterioration, there are several key indicators to look for. For cellulose nitrate film, these include sticky or gummy surface, a pungent odor, and the presence of powder or crystals. For cellulose acetate film, look for shrinkage, warping, brittleness, and a strong vinegar odor. For all types of film, examine the edges for signs of tearing or damage and check the image for fading or discoloration. In terms of storage environment, maintaining a stable temperature and humidity is crucial for all types of film. Fluctuations in temperature and humidity can cause the film to expand and contract, leading to stress and potential damage. Darkness is also important, as prolonged exposure to light can cause the film to fade and lose its color. When handling film, always wear gloves to prevent the transfer of oils and dirt from your hands to the film surface. Use clean, lint-free cloths to wipe the film and avoid using any harsh chemicals or solvents. When rewinding or inspecting film, use specialized equipment designed to minimize the risk of scratches and abrasions. In addition to the NFPA 40 standard, there are other relevant codes and standards that may apply to film storage facilities. These include local building codes, fire codes, and environmental regulations. It is important to consult with local authorities to ensure compliance with all applicable requirements. Furthermore, consider the electrical aspects of film storage. Ensure all electrical equipment within the storage area is properly grounded and meets relevant safety standards. Avoid using extension cords or temporary wiring, as these can pose a fire hazard. Install smoke detectors and fire alarms to provide early warning of any fires. Conduct regular inspections of the storage area to identify and address any potential hazards. This includes checking for leaks, pests, and other conditions that could damage the film. Maintain a detailed inventory of all film stored in the facility, including its type, age, and condition. This information is essential for managing the collection and responding to any emergencies. Develop a comprehensive disaster plan that outlines procedures for protecting the film in the event of a fire, flood, or other disaster. This plan should include provisions for evacuating the film, securing the facility, and contacting emergency services. Train all personnel to handle or store film on proper handling techniques, safety procedures, and emergency response protocols. This training should be conducted regularly and updated as needed. Consider using archival quality storage containers to protect the film from dust, dirt, and other contaminants. These containers are typically made of acid-free materials and are designed to minimize the risk of chemical degradation. When storing film reels, ensure they are properly supported to prevent warping or damage. Use reel cores that are made of inert materials and avoid over-tightening the reels. Regularly monitor the temperature and humidity within the storage area using calibrated instruments. Keep detailed records of these measurements to track any fluctuations and identify potential problems. Consider using a data logger to automatically record temperature and humidity data over time. This data can be used to analyze trends and identify potential issues before they become serious. Implement a pest control program to prevent insects and rodents from damaging the film. Use traps and baits that are specifically designed for use in archival environments and avoid using any chemicals that could harm the film. Finally, remember that film preservation is an ongoing process. Regularly inspect the film, monitor the storage environment, and update your procedures as needed to ensure the long-term preservation of your valuable film collection. Storing film safely requires careful attention to detail and a thorough understanding of the materials involved. By following these guidelines and consulting with experts, you can minimize the risk of damage and ensure that your film collection is preserved for future generations.